for a moment. Right? What we're doing today is we're going to have a video day to give us a foundation for atomic theory. Next week, we're going to really go back to what we were doing before. But I just realized that, hey, we never actually realized why we're doing this in the first place. So that's what today is about. A relaxing day for us to watch some videos, learn a little bit about chemistry fundamentals. All right? At this point, we are doing this. So, please very quietly do your transition due now. I will take attendance, then I will come and stamp you after we go back to the post bell due now.
So,
gentlemen, don't worry about him. To the front, please. No Cantrell. So we got Ellison, Cantrell, and McClellan are missing. So we make this easy, right? Which one's the metal? Which one's the non-metal?
sand it out.
Selenium is the non-metal. So from the answer charts, you guys can remember, hey, who's gaining electrons, who's losing electrons? There we go. Metals are losing, non-metals are gaining.
Thank you, Mr.
Not the one to you.
No brown nose, man. Alright. Now, these three are very simple. As soon as you get the charges, we can move on. So I've just taken attendance. We got 1 minute for you to very quickly do this. If you know the groups, you know the charges. Once you know the charges, formulas are easy. Make sure. Which one's AL? AL is in group 3. So what charge does that ion make? Positive what? Positive 3. Okay, noise level down. Selenium is in group 6. It is non-metal. How many do we need to gain from 6 to 8? 2. So now I have a what charge? Negative 2. Okay?
What'd you say, sir?
Put the cards away, please.
Yes, sir.
Okay. So, 20 seconds. You guys should know the 3 pairs by now. We got aluminum and selenium, titanium, phosphorus, vanadium, and fluorine. Metal is coming first. Okay. Sure we get that down. See Mr. King is finishing up. Yeah. Mr. Martin looks like he's done. Mr. Jordan's singing about atoms. Alright guys, here's the deal. Today, why are we doing this in the first place? What is an atom? Okay? So, before we do anything else, I want you to think. Even if you get the wrong answer, what are the 3 particles that make up the atom? That should be easy. Now the second one, not so much. That's what we're learning today. What do scientists have to do in order to discover these particles? Okay? And finally, why do you think electrons are so important to chemistry? Okay? You got to write it down. We'll have a discussion very soon, but we got to write it down. Jones, you good?
Oh,
Okay? Keep on writing, guys. I'm coming around with stamps. We're on Friday, guys. Almost there.
Stay over there. He's not. Wait.
We definitely know about the subatomic particles. The subatomic particles can also crack open to make even smaller particles. The problem is, we can't really crack open a proton because then that'll open a whole new can of worms. Who got a question? Mr. Henderson had a question. Okay. Mr. Rodney, I'll get you. Boom. Hey, what's up? Who did what with what? Who did what with what? I don't know what to tell you, sir. That's okay. Yeah. It's all good. Okay, somebody. 3 particles. What are the 3 particles? Protons, neutrons, electrons. Thank you, Mr. Townsend. Second. Well, actually, let's do number 3 first, because number 2 is probably something you guys have never thought about before. Number 3. Why are we caring so much about electrons? Why do we do what we do now?
Because the electron makes a charge.
The electron makes a charge. It's a negative charge, right? But why is the electron so much more important right now to us than everything else?
Because every
Okay. So that's just what the molecule is made of. But what is the electron actually doing, gentlemen? It's sending a charge out. So, hold on. Guys? So I'm hearing a lot of charge, 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 right? So we know that electrons have a negative charge.
Correct.
And we know that when we think about electricity, guess what's flowing through the wires in physics? Electrons. But electrons also do something else. What's holding molecules together? Okay. The bonds. What is making up the bonds, guys? And number 3, what is making the bonds? Electrons. And that's why it's so important, because the electrons are what's actually doing most of the chemistry in our bodies. The electrons are holding things together. The electrons are being transferred from one atom to another, or being shared between atoms. So today, what I need you guys to do is get out your own sheet of paper, because we are going to do video notes. We're going to have a relaxing day of video notes, and I'm going to show you some cool videos that we can use to understand chemistry just a little bit. Right? We already watched it.
I want to watch them again.
Okay? So on your sheet of paper that you're going to turn in at the end of the day, what you're going to do is write down these questions very quickly. Alright? In the first video, it's a very short video, but how do we represent an ionic bond? More specifically, so everybody who doesn't have a sheet of paper, raise your hand so Mr. Anderson can give you some. And these are recycled papers. Just use the side that's blank. Put your name on it, please.
No, you're not.
Okay. While Mr. Anderson is passing out the paper, listen to what I have to say. On the first video, we have 3 specific questions that I'm going to ask you. This is about dogs actually teaching you chemistry. Yeah, dogs can be pretty smart, guys. So, we learned about ionic bonds and covalent bonds. These dogs are going to teach you about 3 specific things. Sort of. No, these are real dogs, actually. They're very trained. But how did the doggies represent an ionic bond? How did the doggies represent a covalent bond? And what is so special about the polar covalent bond? So you guys